start, and make sure again that you go through and sign into your calculators if good. Go in, sign into your calculators if you haven't already. It's the same start to every class, every day. So hand those up and over now. Um, and when you came in, you all should have picked up a new note packet for this unit. That's the next set of stuff. One thing there also is waiting for you. Is there anyone in here who has not yet taken the exam? So I know if our cycling, okay. So in any case, and those grades are posted. There's a Math Excel assignment waiting for you. I think I sent you out a message the other day. Is it the 29th? 27th to 27th to 28th. I might have bumped it back a day just because of the cycling of the classes. But in any case, so those are all done. Before we get started on the next unit, there were some of you, and well, I'll deal with it generally because I had to answer like 5 or 6 quasi-panic questions from the other afternoon. There were, looking at your scores on the test, they were sort of bimodal, which means that there's 2 sort of lumpings and 2 groupings of data. There was a grouping that was at about 80, I think it was 88 to 90, constituted about, I remember there's 28 of you, or 26 of you in here. I remember that 88 and up group got 13 or 14 of you. And then there was another clustering of you that was somewhere between like a 72 and an 80. No, I'm sorry, if I remember, it was either like 80 down to 72 or something like that. It was in that cluster. There was very actually few of you that were in like this 80 to 88 region. And so before we go into it, and again, some people, you have to calm down, first of all. But second of all, you have to understand, like on the test, you'll see, I think this is like one of the parts is out of like 32 points. If you need to get a 90 on that, that means that you can't miss more than 3 out of the 32 points, which is a lot, especially considering that like one of the questions was worth 4 points. And if you got none out of the 4 points, that's difficult for you to be at that ultra high level. But the part that really, I guess, thinking about it and looking at it from a removed perspective, I did this with the last block class, so and you don't have to answer if you don't want to, but raise your hand if this situation describes you, that your 4-quarter average was higher than your Regents exam. Raise your hand if you remember that being the case. Okay. So, and the other, nice and high so I can actually get it, because this doesn't, okay. All right, sure, thank you. Because what I need you to understand is, that's called grade inflation, okay? And there are a lot of you who are the victims of it, and it's a wonderful thing to go through and do because I look like a hero. I could give you 90s, like 95s, and be like, oh, terrific, looking at this. You sit here and look and go, oh, Maddie, I know that you don't know how to do any of the questions here, but this is a terrific printing job that you did for your name. And the numbers, you really have a fabulous, you write your 2s wonderfully. I'll give you a 90. And we'll do that for every quarter. And then by the time everything hits the fan on the Regents exam, do you see me? No, not at all. So by the time, the gig is up, all of a sudden you're nowhere to be found. I'm not even accountable to it. And everyone leaves going, you know what, I had so much fun. That, by the way, is the worst. When I put on your course sheet, like describe previous years, if I see fun there, I immediately think less of the teacher that we had previously. There are, like me personally, there are 10,000 adjectives that you can use to describe me. If fun is in the top 1,000, I'm not doing a good job. You should say, this person pushed me, they didn't give up on me, that fun. Darien Lake is fun. Disney is fun. Your teachers are supposed to push you so you can be, engineers and lawyers and doctors that are top-level artists and all of that stuff. And here's the one thing that got me. So I saw from the other group, and it shockingly still holds true. From your Algebra 2 enriched, from your Geo enriched course grade versus the other one, was anybody, and you don't have to answer, did anybody have more than a 5-point discrepancy between their grade and that? You had 1, 2, raise your hand if it's more than 5 points. Raise your hand if your Regents grade was more than 5 points lower than what your course grade was. Nice and high. Don't be ashamed, because again, it's done. So, terrific. Let's see this. Raise your hand if you remember if it was more than 10. Because I'm going to show you right now, this is the thing this is our mindset that needs to change. This is the mindset that needs to change, because then we start going into, well, what about, when are test corrections? Somebody who said that the other day. When are test corrections? We don't do them. You're going to have so many assignments. Show me it's an outlier. Show me. Don't do test corrections. That's garbage. You've already seen the question once. You should know how to answer it the second or third or fourth time you see it. And watch this. I went through. Now, I had to go through and hide their grades. This was for Enriched. So I had a sample size of 50 students on the button. Okay? Now, here is their Regents grade. Here is their average for the 4 quarters. Watch what happens here. All of the yellow means that they scored higher. By the way, is there anybody who scored higher on their Regents grade than they did for their 4 quarters? 1, 2 of you? Thumbs up.
Oh wait, higher than mine.
Higher on the Regents than your 4 quarters? We got 1, 2, 3, 4. Okay? Less than 10%, or sorry, less than 25% of our group had it. Now, looking at what this is, the ones in red, the numbers in red here are the ones that scored lower on the Regents exam than their quarter grades. It happened here, and look at that again. We can go through and argue about what these things accomplish and what they don't, but this, to my perspective, this is what you're going to face. I don't care, and this is another thing. Some of you sit here and go, well, I don't know if I get nervous, I feel like I should go. Stop it. I'll tell you right now, I couldn't have drafted a better team if I tried. I'm so glad that every one of you is here, because believe it or not, whether you have the ability, whether you think you have the ability or not only are you going to get there, but I can't wait to get you there. Looking at this, these are the students. They scored exactly what their Regents was their 4-quarter average. This was their, this person scored 4 points higher on the Regents. All the yellows are higher, but look at the discrepancy in the ones who weren't high. This person was off by 1 point. This person was off by 2 points. Now we get into some huge discrepancies. 1 point. Look at 7 points, 6 points higher up, 4 points. The biggest discrepancy I had, none of you, oh, wait a minute. There's a negative here for some reason that's not highlighted. Okay, was 9 points here, and 4 points and 5 points after that. But again, notice how when you don't go through and give fluff, we get an accurate measurement of what it is. My goal for you is to be successful. I will never, ever, ever tell any of you that you can't do it, period. Because every one of you can. The other end of it, though, is we have to strip away the excuses. Because that's another thing. It's everything from I'm a bad test taker to when are we doing test corrections, blah, blah, blah. If you open the door to enabling people, they go through and they will absolutely take advantage of it. And you all are conditioned to take advantage of it. You take a bunch of grades in here. Because I want you to be comfortable taking tests. Because I don't know if you realize this, once you go off to college and you don't, if you're getting nervous or things like that on tests, it just means that you're going to have a really, really tough time being successful. Every single one of you is going to go through and be successful. Without a doubt. Look, and again, the lowest grade that I had, the absolute lowest, I had 2 students who got a 65. And the class average, I think we only had one 100. There were a couple 99s, 98, etc. But in any case, I look at that, and this I don't even view as successful. The class average was something in the mid to high 80s. And looking at, going back and looking, there were some of you who, overall, that was not the Geo enriched average. I'm going to tell you this nicely. You all have to believe in yourselves a little bit more. Because it's very easy to sit there and go, I can't. I'm telling you right now, not only can you, but you're going to. Because when we're successful here, all of these doors start to open up. Next year, you can take pre-calc for 4 college credits if you get above an 83. By the way, that's why all of these, and I don't know, something changed with this rule that I put in this Excel function. But in any case, every Regents grade above an 83, allows you to take pre-calculus as a 4-credit college course as a junior. You should also be taking AP Statistics next year, which means you'll be taking a total of 7 college credits. Then when you get to your senior year, you'll be taking calculus, AB calculus or BC. And that's going to open the door to 4 more credits. You can go through and take some computer programming class. That could open the door to 4 more. But I'm telling you, you have to get past this. I can't tell you how excited I am to work with you. But some of you've got to believe in yourself. And there's little things, and you'll sit there and go, I can't believe I made this mistake. And it happens. There's questions on there like, what was there was one. There was a ton of questions that we had on, and I'll show you towards the end once everybody's done. There was one like about, where do we have to restrict the domain of this function such that the inverse will also be a function? Something like that, and people are like, well, I don't know how to do that. That means you didn't know as much as you needed to. It doesn't mean you're a bad person. It doesn't mean you're a bad student at all. And I told you, I'm going to throw the kitchen sink at you because that's the only way you get better. I know you're good at solving 5x plus 2 is equal to 7. And then everyone goes, oh, this is this. I sit there and go, when did they do quadratic equations last year? They go, we should probably work more of that in. Terrific. That's fine. But I know now, coming in, that you all haven't done quadratics before. Since I knew that, I figured, hey, let's start the year off with it. Let's stop avoiding the stuff that's difficult. Because again, you're going to hit the wall eventually. You couldn't hit the wall with a better person than me. Because I'm not going to give up on any single one of you. And you're going to do so well at success. You could draw pictures, right, of knives going into my eyes and say this crazy old bat sits there and he yells at us all the time. He went through and yelled. And one kid I had tell me as we were walking through the hall, it was an Enriched kid from 2 years ago. And I go, you only got a 93 on that exam. And he looked at me. And he held up, I'm assuming a finger to indicate I was number 1, and then walked away. And then it was funny because at graduation he came up to me afterwards. And he said, you know, it was kind of funny. And I said, what? And he goes, I remember you didn't write me up after I gave you a salute. And he goes, I actually thought about that a lot. And he goes, that was the first time that anybody told me I could do better than when I thought I did well. And it's the same for all of you. You may get congratulations and high fives for getting an 85. But the minute you hit 85, that to me indicates you can get an 86. So every one of you, again, I'll sit there and I will push in, again, you're like little tubes of toothpaste. I will get every bit of toothpaste out of you. I will squeeze if I have to, that tube. I don't care how much it's uncomfortable for you. Get over it. I'd rather you hate me and get a 95. And then you can go, that's the other thing. Talk to your friends when it comes up. Find out how they did. Because you'll sit there and go, God, I got a 96 on that exam. I was all right. I probably could have done a little bit. I missed a stupid point or something. And then you go to your friends, how did you do? And go, 61? You're right. I should sit here and we should do movies every day. That's what I feel like sometimes. And then I would be so popular and it would be so terrific. And everyone would go, oh, we had fun today. We watched movies and we discussed our feelings. We did an interpretive dance and then test corrections. I mean, get real. That's the stuff that's going on. You have to push yourself more. Yes?
For the calculus courses, which one is more difficult?
The BC calculus course is the toughest of the top.
Okay.
That is the Mount Everest of high school math. But the thing that's so funny even about that, what makes it, the Mount Everest, it's got 2 or 3 more units in it. That's it. AP Calc is the same thing. And again, you're here to take those courses. stop selling yourself short. I don't know why or where you all lost some form of self-confidence or self-rigor, but by and large, you have. You can't quit on yourself. That's the worst thing that you could do. What?
Then how come some people take calculus BC before AB?
You wouldn't never do that.
Oh.
Doesn't happen that way. Now, let's take a look at what we have to start. You all should have picked up, oh, here's another thing. Shh. To save the copier, if you go in and you need it, your homework for this unit is here. Thank you. You can download it, save it to Google Drive, whatever you want. But here is your Algebra 2 homework assignment. It's posted. You do the questions. Now, I did them as text boxes in Excel, or in Microsoft Word, so you'll see sometimes it may snake from page to page. If it references a question that's not there, just go on beyond it. I tried to clean up some of the answers. Some have this and additional work. They should be done on separate paper, yada yada. Now, let's go over, please, and we'll begin. We left off here. We're going to start off with radicals. And the work that we do this unit is maybe slightly easier. It's more algebra-based than the other stuff. With the other stuff, we should have been review anyway. So the first thing that you need to make sure that we have down is every positive number has two square roots. One positive and one negative. So when I take the square root of 25, I'm asking myself what times itself gives me 25. There are two values such that we get out a 25. One's positive, one's negative. Yes? There you go. The principal square root is the positive only. But you need to know that there are two. The square root of a negative number is not a real number. That's something that you all need to make sure you have down as well. The square root of a negative number is not a real number. So you can't take the square root of negative 16 yet. You can take it after, I think, once we get a couple of days into this unit. Questions on that? If you are taking something like this, if you see this, you should know that this is going to have two answers. And you should also know that the square root of 16 is equal to 4. That has one answer. They're different things. One, the square root was given, and one, we need to take a square root to get the answers. Easy way to remember again is the degree tells you what that's going to end up being. Questions on that? Let's bounce forward to the next group. If I'm going to take the square root of 169, looking at what's there without going into the calculator, Alexa, what do you say the square root of 169 is? Do you know? What's that? 13. Next one up, how about if we go through and solve this out for x? Now, how many answers, Peter, is this going to have to start? 2. What would you do to solve it out first, Peter? Okay, so what would you write out now? What would we go through and do next? Emma K? Good, so what are you going to be left with? Nope. Hands up, please, and tell me why that's incorrect. 3, 4. Yeah, it's plus or minus. That's the thing we've got to go through and get used to. If you see that square there, you've got to make sure that that's...
Mr. Brown,
Yes.
how come on number 1 though, you don't put the positive one or positive number?
Because you're taking the square root of the square root was given, okay? The square root was given. You didn't have to insert it into the question. There's only, if you take the square root of 169, that's 13. If it's x squared equals 169, it's plus or minus 13.
Oh, okay, sorry.
Mm-hmm. Let's go through and do some more. Take a look at the one over on number 3. And looking at number 3, counting B, how many answers is this going to have? Yeah, it's going to have 2. What's your first step going to be?
To add 49.
Okay, so let's add the 49 over. So I have 4x squared is equal to 49. Keep going. What do you do next? Okay, so I would now write out x squared is equal to 49 over 4. What would we do next from here? Vicki?
You would square root of.
Now, again, we don't need to go to the calculator. That means that x would be equal to what? Jason?
3.5.
No.
Oh, wait. Oh, yeah, sorry. 7 divided by 2.
Well,
Just, I simplified it.
no. You're missing something there.
There's a 7 over 6.
Nope. Oh, that's the other one. Yeah, the plus or a minus. Again, we have to get, if you're solving it as part of the equation, it's plus or minus. Questions on this? Yeah.
Should we simplify even more to 3.5?
No. And that's another thing. Some of you give things like this. That never happens anymore. That's not a thing that we do. It's more work, and no one past, 7th grade uses those anymore. Take a look at the next one. Hopefully we get this one right. Sarah Al, how many answers is this going to have?
2.
2. Keep that in mind. Our next step is going to be to go through and take the square root of both sides. So I'd have x is equal to plus or minus. Radical 50 is not a perfect square. However, hopefully you can recall, it does have a perfect square as a factor. I've got 2 of us that can tell me. 3, 4, 5. Oh, we're better than this. Who can tell me what perfect square number goes into 50? 25 times what? So this would be plus or minus, and I'm going to rewrite this as a product because we can take the square root and break that radical down. When I take the square root of it, Chloe, what is the square root of 25? So my final answer would be x is equal to plus or minus. There's a 5 as a coefficient, 5 times radical 2. Questions on that? Let's simplify out what's there. Do I have the perfect square list? Yeah, let's make a list over in the margin. Your perfect squares, 1 is a perfect square, but we don't normally count it. It goes 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 256, and it continues on. The other perfect squares that you need to know that for some reason that you don't see, or at least they didn't, maybe they did it with you back in algebra or not, you have to know that when you take the square root of x squared, that's going to be an x. If you take the square root, it's plus or minus. If I take the square root of x to the 4th, that would be x squared, because what times itself gives you x to the 4th. You need to know that when you multiply with like bases, you add the exponents. If I have x to the 10th and I take the square root of that, that would go to x to the 5th. The other roots that you need to go through and know is, and this is stuff you should be able to do in your head, if I take the square root of x to the 9th, actually let's do out x to the 11th, the square root of x to the 11th. You can break this up such that it is x to the 10th times x, which means this becomes x to the 5th with a root x, or with an x still in the radicand. Because you're asking yourself, how many times does the index value, this is a square root, how many times does this index value go into this value here? How many times does 2 go into 11? That would be 5 with the remainder of 1. How many times does 2 go into 10? That's 5. 2 goes into 4 twice. What if I gave you something like this, or asked you to take the square root of, let's say, x to the 101st and y to the 48th power? Hands up, please, if you can tell me what you think that would simplify down to be. In terms of 2 separate radicals, what would the x to the 101st power simplify down to? X to the 50th, and then there would be a root x left over because 2 goes into 100 50 times with a remainder of 1, and 2 goes into 48 how many times? Is there any remainder when 2 goes into 48? No. That's the same process. Yes?
Does it have to be in this order?
What do you mean by that? You wouldn't, I'll say this, you wouldn't list it out as x to the 50th times radical x, then times y to the 40th. Is that what you were asking?
Yeah.
Okay. Because we have, these are called coefficients. So this would have 2 coefficients, and just so we're aware, this is x to the 50th times y to the 24th times that. And you can separate out that addition, or sorry, that bond, multiplication bond. Looking at what's there, let's do out now. Question number 5. Hands up, please, if you can tell me what number 5 would simplify down to be. We've got one person, we'll wait for 7. We've got 2, 3, 4, thank you, 5, 6,
15.
terrific. How about for number 6? We've got 1, 2. Alyssa, what do you say? Now, if this helps to do a breakdown like this, go right ahead and do it. I look at this, there's no perfect squares in number 7, so what I'm going to do is I'm going to list this out and I'm going to start breaking it down. I've got 12. Well, 12 isn't a perfect square, but it has perfect square factors. Who can tell me how I would break down 12 such that it can be simplified? We got 2 people, 3, 4. Jeff, what do you say? What perfect square goes into 12? 4 times what? Good. So I break this up to 4 times 3. Now, x to the 9 isn't a perfect square, but there's one below it, or a way I can break it up such that the taking of the square root is a little bit easier. It'll be x to the 8 times x. Y to the 14th is a perfect square. If that helps, if you need to see it this way, then do it this way. What perfect squares, Trevor, are in the radicand now?
It would be x to the 4th and y to the 3rd.
This is x to the 4th. This would become y to the 7th. And what else?
Oh, and 4, there'd be 2.
So, what are your coefficients in front of the radicand, Noah, going to be?
2, 2,
And then in the radicand, what are we left with? Yep. Go through and do out number 8 on your own. I'm going to ask, how do you want to break that down? Mm-hmm.
100 times 2 is 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. 2
Kaylee, what can you take the square root of that we just listed out? Anything else? Ian? Can you give me what your final then would be? Questions on that? Now, the next thing that we're going to talk about is cube roots. And that's the same thing as a square root, except you're saying not what times itself twice, but what times itself 3 times will give you these values. Now, 1 again is going to be a perfect cube. We don't. Our perfect cube numbers, 1 is 1, but we don't really use it. So the first one up is 2 to the third, and 2 to the third is 8. 3 to the third is 27. 4 to the third is 64. 5 to the third is going to be 125. 6 to the third would be 6 times 6, which is how much? 36. 36 then times 6 again would be how much? 216. And you can generate this list if you have a calculator with you at any time. You can literally go 1 to the third, 2 to the third, 3 to the third, and so on. Now, and I think that the next one's 343. Now, and the list would continue on forever. Now, the other thing is, let's deal with some of the roots that you're going to encounter. If I have the third root of m to the third, that would be m. Because you're asking yourself, how many times does the index go into the exponent? The index is the number in front. So if I gave you the third root of m to the fifth, hands up please if you can give me a guess as to what you think that would simplify down to be. The third root of m to the fifth, we got 1 person, 2, 3, think your way through it. It's not like it's a different pattern than before. What do you want to say? No? M, and then the cube root of m to the second. How many times does 3 go into 5? Once, with a remainder of 2. Hands up, please, if you can tell me what the cube root of, or third root, either one is acceptable, the cube root of m to the 10th will be. We've got 1 person. We'll wait for 6 of us. We've got 2, 3. It's the same pattern. You've got to be able to go through and follow. 4. What do you want to say?
M to the third times cube root of m.
Terrific. Make sure you understand this. If you don't do it right, starts to look like it's m to the third here. That's not the case. The index is like on the perch of the radical. Now, here's one too that some of you will struggle with. You can evaluate the cube root of -8. You cannot take the square root of -8 yet. You can take the cube root of it. Who can tell me what the cube root of -8 is going to be? We've got 3 people. 4. What do you want to say? Why did you say -2? There you go. Now, what that means is we've unlocked the ability to take the cube root or any odd numbered root of a negative radicand. This would be -2. Let's look at what's up there. The cube root of 64p to the 12th, that one should be easy for us, hopefully. Taylor, what do you say that that would be? What's that? P to the fourth, yes. If you're asking yourself how many times does the index go into the exponent, which would be
4.
no remainder, so no radicand. How about for number 10? If we were to go through for number 10, this one's actually easy as well. It doesn't look like it is, but if you've been with us, this should be simple. Courtney, what would you want to try for that? Let's do it in parts. What's the cube root of negative 27 going to be? What's the cube root of m to the 6th going to be? And? Is there anything left in the radicand? Easy. Go through right now, please, and do out the next two on your own. Go through and do out the next two on your own. Use your calculator if you need it. Allison, how do you want it? Now, is 16 a perfect cube? Let's start off with that. So how do you want to break it down? Okay? Okay. Now, what did you list out right now that you can go through and take the square root, or sorry, cube root up?
8.
Terrific. What else?
And then C cubed and C, and then D to the 6th.
Mandy, what would you give out as your final then? Careful. I didn't hear that. Yeah, what else? Yeah. Questions on that? Next one up. I want to break down number 12. Who got 81 is not a perfect cube, but it has a perfect cube factor. Who can tell me which one we would want to pick? Careful. I want to do the negative 27, yeah. So I'm going to do negative 27. Now, who can break down the variables? This would be 27, negative 27 and 3. Who can break down the variables further? We got one person. How do you want to split up those variables that are there? Jonathan, what do you say?
Times m to the 9.
Good, so we've got m to the 9th times m, and then the n to the 12th we're good with. What can I take the cube root of, Tyler, that's there? Is? What else? Is? And? What would you give then as your final answer? Jess, what do you say? What? Go ahead, Seth.
Negative 3 times 3 times 4.
And then,
Cube root
good. Of?
3x.
Perfect. Questions on that?
How did you guys get the square root of 3m?
You mean the cube root
Or cube root, sorry, yeah, because I just got
of
cube root.
this right here?
Yeah.
Because it's m to the 9.
No, I'm sorry, in the red.
In the radicand, because that's what's left over. We weren't able to take the cube root of 3 or the cube root of m. So if you can't take it, you leave it in the radicand.
I see what I did.
Okay? Now, we're going to try some that are perfect fourths. Now, I don't have these memorized, but I can do them pretty easily. You can go into your calculator if you need help with it, but let 1 obviously is one of them. That's not going to help you at all. 2 times 2 is going to be 4. Times 2 again is? Times 2 again is? 16. All right, so I know one of my perfect fourths is 16. That's 2 to the 4th. Hands up, please, if you can tell me what 3 to the 4th is going to be. We got 1, 2.
81.
81. Terrific. That's 2, 3. How about 4 to the 4th? Hands up, please, if you can tell me that. 4 to the 4th? 256. 5 to the 4th, hands up please if you can tell me that, Tyler. 625, and you can keep going down that list if you need to. Now, looking at what's there, by the way, let's do this as well. What if I take the 4th root of x to the 8th? Hands up please if you can tell me what the 4th root of x to the 8th is going to be. We've got 1, 2, 3. I couldn't hear you. X what? Terrific. Because you're seeing how many times does your index go into your exponent. What about this? What's the 4th root of x to the 15th going to come out to be? Hands up, please, if you can tell me that. What's the 4th root of x to the 15th going to come out to be?
To the 3rd times the 4th root of x over 3.
Because 3 does not go into 15 exactly. What multiple of 3, or how many times does 3 go into 15? How many times does 3 go into 15? Or sorry, I said 3, I'm sorry. How many times does 4 go into 15? I'm sorry. How many times does 4 go into 15? 3 times. There's one problem though. What's left over? 4 goes into, at 3 times, that gets you to 12. So you've taken care of 12 of them. How many are left over?
3.
3 of them. Now, what if I gave you the 4th root of x to the 21st? Hands up, please, if you can tell me what that would be. The 4th root of x to the 21st power. We've got 2, 3 of you. Eli, what do you say? How many times does 4 go into 21? 5. So you've got x to the 5th out front. What's left over? Looking at what's there, let's break down. We should be able to get done 13 quickly. Hands up, please, if you can tell me what 13 is going to simplify to. Really? Terrific. Alyssa, what do you say? What times itself 4 times gives you 81? You listed it out in the margin. It's a perfect fourth. You can go to the calculator. Yeah. And by the way, here's one thing, and I forgot to show you here. You can take these odd roots by that. Go into a doc here, whoever this is. You can find it if you press Control and then the caret button. So do that out, please. Hit Control and then the caret. Take in, this is the 4th root now. So in the index, put a 4, the 4th root of 81, and press Enter. Now, sometimes it'll give you a decimal approximation. Odds are, unless it's some sort of applied mathematics question, you wouldn't need that. So your answer would come out to be a 3. So keep going then. C to what power? Sorry, I couldn't hear you. 3, good. And then D to what power? Yeah. Is there anything left in the radicand? No. We took care of everything. It's all out there. How do I want to break down number 14? Michael, what do you say?
Virtually 32 down into 16 and 2.
Okay, so 16 times 2. What about the m to the 10th? That's not going to work out nicely.
Break it down into m to the 8 squared.
And then n to the 12th is good. What can I take the 4th root of that's currently there? Jensen? Okay. And what's the 4th root of 16? Is what? No. 2. What else can we take the 4th root of, Jensen? And what would you get if you took the 4th root of m to the 8? And what else? Which is? So now, what would you list out, Alexa, as your final answer?
2m squared, m to the 3rd, 4th.
Technically, there's more since you can take 4 over 2 and reduce it, but we won't. Now, the next thing that we're going to do is to rationalize our denominators. You're not allowed to go through and leave a radical in the denominator. That's not permitted. So there's more than one way that we can make it happen. Right now, there's a radical in the denominator, and hopefully we're all in concurrence that if you multiply a fraction by 1, you are not changing its value. If you multiply a fraction by 1, you are not changing its value. And 1 takes on a lot of forms. 1 is a simple, beautiful number, but, square root of 86 over the square root of 86 is also a really ugly way to get 1. We're going to need to find and ask ourselves this question, because some people show this as something that you sort of put on autopilot, and that's not the best way to do it. So let's ask ourselves this. What's the smallest, in this case it's perfect square, what's the smallest perfect square that 5 multiplies into? Hands up, please, when you can tell me. What's the smallest perfect square number, because we're dealing with square roots, that 5 multiplies into? We have 2 people, seriously, that can tell me the smallest perfect square that 5 goes into? Holy cow. 25. What do I need to multiply 5 by to make it go into 25? 5. So I'm going to need to multiply this by a radical 5. But we're going to modify the expression unless the value we multiply by is a 1. So in the numerator, I'm multiplying by that as well. This is just an ugly 1. When we multiply going across, there's no coefficient, so it's 1 times 1. And then the radicands themselves would give me root 60 when you multiply them together over root 25. The square root of 25, though, is the square root of 60. Now, go in right now. Go into your calculators. Let's see what perfect squares go into 60. I know 50, and 50 is not a perfect square. Hands up, please, when you can tell me a perfect square number that goes into 60. We got 1, 2 people. Got to be quicker. And again, there's no staring, there's typing. We got 3, 4. What perfect square number goes into 60? 4 times what?
15.
Okay, so when you take the square root of that, the square root of 4 is 2, root 15. That's your final answer. 2 over 5 does not reduce down. You're smart enough to be able to take the square root of 4 in your head. Questions on what we did here? Let's continue over for number 16. Now, this again, you have to ask yourself a question. What is the smallest perfect square that 8x will multiply into? Hands up, please, if you can tell me the smallest perfect square that 8x will multiply into. Because we can make it happen. 8x, what's the smallest perfect square that it goes into? Close. You took care of the number. You didn't do the x part, though. 16x squared. So what do I have to multiply this by such that it goes in my denominator is 16x squared? Hands up, please, if you can tell me. What ugly one am I going to use to make it such that my denominator is 16x squared? Well, terrific. So I'm going to multiply my numerator and my denominator by radical 2x. That means up top I would have the square root of 10x, and then down below I have the square root of 16x squared. Do any perfect squares go into 10? Not exactly. You can't simplify down the x, so you've got root 10x, and then in the denominator, root 16x squared. Well, what's that going to be? 4x. You cannot simplify out a number that is outside of a radicand with a number underneath a radicand. Next one up, you have this awkward fraction. This is the same as radical x over radical 2. Hands up, please, if you can tell me what ugly one I would use to rationalize this. All I'm doing is multiplying by an ugly one to cause a perfect square to happen. What do we get then, Peter, in the numerator? Multiply across, what would you have? Good. How about in the denominator? Radical 4, which is just the 2. This one is a cube root. So if we did out a cube root, I'd break it up. It's the cube root of x squared. We can't simplify it. The cube root of 3y. What do I need to multiply this by in order to get a perfect cube? Well, what's the smallest perfect cube that 3 goes into? 9. Careful. Not the one that it goes into is not 9. What's the smallest perfect cube, not square, cube that it goes into? 27. How do we make that happen? What would I need to multiply this by so I would get a perfect cube down in the denominator? The cube root of 9, and then what else? It's a perfect cube, not a perfect square. Say it.
Y cubed.
No, y cubed gives me too much. We need it to be y cubed. Y squared. So now, I'll finish this up. Your homework is listed. It's on there. Make sure it's on separate paper. Please be ready to hand it in next time we have class. That's number 1. Number 2, you've got that Math Excel assignment waiting for you. I think I bumped it back to at least a 28. But go in and check. Don't wait until it's the last minute, because if there's a computer problem, that's tough. The homework themselves are posted. The homework is posted through Google Classroom. If you want to, yeah.
Oh.
The other ones, the homework should be adequate practice for you. It's from the packet. Instead of giving you a physical printout, if I put it in Google Classroom, they yell at me about the number of times. They're very easy. And you have to test and adapt. But you have three. Okay, there's only one period. Wait a minute, guys. You haven't taken the test yet, correct, or have you? You haven't? Okay, hang on, please. You need to go through and, so what day is today? Is it weekend? Okay, so, when are you going to, 4 o'clock tomorrow? Okay, that's fine. You're gonna have to take down the math that though. You need to come and see me first. Okay?
What?
All right, I'll have to go and check. Okay? Oh, there's some that I didn't look at. There's some that I didn't look at. That's right. I remember. I'm sorry. Thank you very much. Hang on, guys. 1 second.
You want them to help you?
What a nice person. Hang on 1 second. Make sure you can pick up the calculator later. Get started right now if you want.
See you later, Mr. Master.
We'll see you later, bud. Yes, your phones go up here. You can pick a place